Okay, so this week we are going to go over sections 1.3, 1.4, and 1.5. This first video is just going to be on 1.3, and I'll add the 1.4 and 1.5 shortly. Just a reminder, like always, your quiz from last week, week 1, is due on Monday night, and that's the quiz. So make sure you're done with your homework and the quiz, all that. You should be good to go. So today, like I said, I'm going to look at 1.3. Just kind of walk you through all this stuff, and then I'll do a couple of problems at the end. Okay, so mathematical modeling, one of the topics we're going to be doing: linear functions, equations, and inequalities, quadratic functions, equations, and inequalities, properties of quadratic functions and their graphs, applications of linear and quadratic functions, linear and quadratic regression. So, in terms of modeling, basically, as you might know, this is just getting some real-world word problems is what we're doing. So we're going to try to set them up, make sure that you can take a problem and you can kind of figure out what the problem is asking, set it up with an equation, and then get the equation at the end. So constructing the model, solving the model, and then the important part at the end is interpreting the solution. A lot of times students will set it up correctly, they'll solve it correctly, and then they'll forget to answer the question. They'll forget to take their answer and use it properly. Okay, so we kind of have a little graph here, a little idea that you can see what you're going to be doing. And you've got a problem, you're going to construct it down to the bottom right, you're going to make that equation pretty much right there. You're going to solve the equation, interpret it, and the whole idea is that you now have answered the question they've asked. So I'm going to go through all these steps, but all three of these parts are vital when you're doing these things, okay? And then they bring it up there in a real complex problem, real world. You may have to go through this multiple times, to get a final answer, go through the whole cycle. Okay, so linear equations in two variables, which is most of the time what we're going to be dealing with. You have your equation that has an x and a y, and then in that standard form they talk about here with this ax plus by equals c, that's your standard form for most equations. Now, at times you're going to see me bounce back and forth, and you remember your algebra where you have this type of equation for the line. Then, of course, we have our parabola and cube and other equations, things like that. But both of these are identical, as in they both represent lines. That's where the linear equation part comes in. But it's the format. They're in different forms, but they could be the same thing. In this case, we're going to focus on the ax plus by equals c. A, b, and c are constants. Now, when I say constants, generally that means any number, positive or negative or 0. In this particular case, though, a and b are not going to be 0, but the c could be a 0. Just different numbers here is what they are. So you'll see some examples in a second of what we might be getting here. So you have your constants, you have your a and b not 0, x and y are the variables. So every equation is going to have that x, y. And just an example. That might be one example. Or it could be something like negative 2x plus 11 halves y equals negative 13. Any kind of weird equation, anything like that. Again, that's your A, that's your B, that's your C. That's the idea here between all of these, what we're talking about when I say standard form, where you're going to see the x and the y. It's that you're going to have different numbers in place of the A, B, and C, depending on, of course, what the equation is representing. So we get theorems here. We're going to get lots of formulas and equations and steps to take, procedures to take here. So if you have any kind of a line right here, if that A is 0, you're going to get a horizontal line. And just a reminder, horizontal is when we're going right to left. It's not angling up like this. It's not angling down like that. It's straight right to left, perfectly level horizontal. That's what you're going to have. So again, basically what it means is there's no x term. If you have just a y equals some number, or some number times y equals another number, you're going to get the horizontal line. And on the other hand, if the b is 0, that means there is no y term, and you have ax equals some number. Something times x equals some number. That's, of course, where we have our vertical line going straight up and down like that right there. Okay, now in the applications that we're going to be dealing with in this business phase here, you generally aren't going to get any vertical lines because number one, they're not functions, and number two, they don't really represent anything that's typical in what you're dealing with. But the horizontal line could happen. Most of the time it's going to be a slope or a parabola, but it's possible those, the other ones, and they're just bringing up the vertical line here as an example. All right, any line graph in the Cartesian coordinate system is a graph of an equation of this form. Now when we say Cartesian coordinate system, that's the XY axis, kind of like this right here. That's what they're talking about, an XY plane or an XY graphing system. So if you have 2 points, x1, y1, x2, y2, and as long as the x's are not the same, then you have that old slope of a line. And I know you've seen this slope of a line many times before in algebra. That slope is still true. That's going to be vital. Slope, so we're clear, is telling us what the pitch is, what the grade is, what the steepness is, and has to do with how far your line is tilted. Something like this has a really big slope, whereas something that's almost flat has a smaller slope. And of course, there's your zero slope, and I'll write over here. These are different versions of negative slopes. And I always tell people, if you travel on the line from left to right and it goes up, it's a positive slope. If it goes down, it's a negative slope. If it goes flat, like that one on the bottom, that's your zero slope. So you have this line here. Any 2 points is all you need to make up a line. And we have one example right here. Then, again, kind of summarizing what I just said, positive is when it's kind of going up, and again, from left to right. Negative, from left to right, it drops. Horizontal, it's flat. And of course, the vertical, and this is important, the slope is not defined. Okay, and a lot of people see this. Here the slope is 0, here the slope is a positive number, here it's a negative number. Talking about the slope. On this vertical line, it means the slope does not exist. It's not defined. It does not mean that the line doesn't exist. A lot of people see that and they think, oh, there's no line, there's no equation. There is an equation, which we talked about earlier. There just isn't a slope. That one part doesn't exist. Okay, so we have all the different forms, and like I said, we talked about this ax plus by equals c. I mentioned the slope-intercept from before. This is the old point-slope form, and then you have your horizontal and vertical lines like this. So these are all different forms. We're going to bounce around between them just to show you what the different ones are. So, equation of a line. We have a line with a slope passing through the point 2,5. Find an equation of this line in the point-slope form, the slope-intercept form, and the standard form. So let me go back one right here. So here's the key. Every equation is going to tell you what's going on. When they talk about a slope and they want to find an equation, we're going to use one of these two. Okay, the y equals mx plus b, or the y minus y1 equals m times x minus x1. And what's key here is this tells you what you need. All right, you need to have those two items to get this equation. So in order to use the point-slope form, someone's got to tell me, or I got to figure out what the m is and the b is. If I can't get those two things, then I can't use this. Whereas in the point-slope form, someone's got to tell me a point and a slope. Either of those two, but the key is, in order to use both of these, they have to have the slope. That's a given. No slope, no equation, at least for right now. So if you don't see the slope, go find it. If they do give it to you, it's going to be one of these. And remember, point-slope form, probably a harder equation. It works with any point, whereas this one, I need to have that b. I need to have a point that's a y-intercept. And so we're all clear. Y-intercepts, where you hit the y-axis, and it always looks like this. It's 0, something. So if you're given a point and they tell you, oh yeah, it hits the y-intercept here, it hits the y-axis here, or they tell you a point 0, something, then you're going to use that equation. If not, we're going to use the second one. So here they tell us we have a slope, and I'm going to write the information I have right now. I have a slope of 3. Well, I'll leave that out for a second. And I have a point. Let's write the point. So the question is, if that point you have is a 0, something, then you have the y-intercept. If it's not, like it is not in this case, then you just have a regular point. In order to do that, we have to use this point slope form right here. Okay, the other one right here, because we do not know what the the b is, we can't use that equation. All right, so we do have a point we can use this, and we're just going to plug pieces in. And so you're clear, this is the x1, this is the y1, and of course 3 is the slope, and we replace this, and this when you find it out. So we pop in the 5, I'm sorry, so it's y minus 5. We put in the 3 for the slope, we put in the 2 for the y1, and we get this, and then we just have to clean it up. So that's in point slope form, and this is actually done right here. This satisfies this first part. Now you got to get it in the slope-intercept form, which is the part I had right here, this y equals mx plus b. In order to do that, just remember what that means is solve for y. That's what we're going to be doing next here. We're going to solve for y, get y by itself. So they move over the 5, which is fine, or you could distribute the 3 first. And the step they didn't show right here is if you distribute that 3, you get y equals 3x minus 6 plus 5. Then it becomes that one right there. And now we have the slope-intercept form. Okay, then the last part is to get it into standard form, and I'll write under here, this is your standard form, that ax plus by equals c. One of the things here too, and I didn't mention this earlier, I might have said the other thing, but normally when you have the ax and the ax plus by equals c form, you usually don't have any fractions. So a is a whole number, b is a whole number, c is a whole number. So we want to get rid of fractions. Well, in this form, this y equals 3x minus 1, there are no fractions. All I want to do is I want to put the x and the y on one side and the number on the other. And it was one easy fix right here. If there was a fraction, say in the slope, you would multiply every term by that denominator and you'd get the answer. You'll see that on a future exam. So that's what the deal is for this one. All right, so let's look at another one here. We have a linear function. All right. These are all linear functions, but we have this y equals mx plus b, f of x equals mx plus b. So here's an example of a problem we have. Student organization is planning an event that intends to sell custom printed t-shirts. The committee found the company will create artwork for a fee of $175. Then the company will print the shirts in various sizes for $4.75 per shirt. The organization plans to sell the shirts for $12. So to add some clarification on that one, doesn't matter how many shirts you order. If you've ever done this before, the $175 is a fee just for designing. So whether you make one shirt or you make 1,000 shirts, there's a fee of $175. Then there's going to be the fee per shirt. So the flat fee is the $175. The variable cost is the $4.75, because that depends on how many you order. So what they're asking us to do here is we are going to write a function that's going to give us the total cost for printing and the shirts based on the number of shirts printed. Okay, so when you're doing these, then we have to write a function, to give the revenue from these. So first off, let's look at, we got the fixed cost that I talked about, we have the variable cost. Now remember, fixed cost is the same no matter how many shirts. The variable cost is going to vary on how many shirts you sell. So they work on this, and the first thing I like to make sure to make it very clear is if you're going to use a variable, you need to define it. Now sometimes you'll have somebody say over here, X is the number of shirts, or they tell us right there X represents the number of shirts. Either way, you just want to make sure when you introduce a new variable, it's clear what it stands for. And as you see how they get this, this is the cost, X is the number of shirts. So no matter what, it's going to be the $175, that's a given, and then this price will go up depending on how many shirts you get. That's the cost function. That's the first thing they're asking us to find. Okay, so the shirts are going to sell for $12 each. Now we have a revenue function, and this one's a lot easier where The revenue is simply $12 times X. If I sell 10 shirts, it's 12 times 10. If I sell 100 shirts, it's 12 times 100. Whatever X is, whatever the number of shirts are, it's going to be 12 times that. And then, so we know how much the revenue is. We know how much the cost is. Now we're going to figure out our break-even point. Okay, and this is important for business here. Whatever the cost and the revenue, when they're equal, that's when essentially whatever I sell and whatever I bring in as revenue and whatever I cost, when they're equal, that tells me how many shirts I need to break even. So you set these two equations equal. The first one and the second one, you set them equal, and then you're going to solve for X. Now, they didn't show the work here, but take this equation down here. We move the 475X over, and then we get 175 equals, it looks like 7.25X. Divide both sides by 7.25, and that's where this 24 came from. Okay, and notice they rounded this to the nearest whole number. Now, if I get a calculator, I don't know if my calculator is going to show on this screen. Might not. But if you go back one, if you take this, let's clear the screen for a second. Now remember what I was saying. That was 175 divided by 7.75, and it comes out to be, nope, not wrong, 7.25. 175 divided by 7.25 gets you 24.13. So essentially, if you sell 24.1379 shirts, you'll exactly earn enough money to cover all of your costs. And then the good news is, after that, every shirt you make is going to be a profit, because when you make one more shirt, it's going to cost another $4.75, but you're going to sell it for 12. So you're making more and more profit if you sell 25, 26, 27 shirts. But that's your break-even point right there. That's the part we want to make sure you see. So, go back there. Okay. So, just going through this process again here. There's your 24s. How many shirts? And remember, this is important. X is 24. Okay, right there. That's your 24. That means, what is X? Well, we talked about that earlier. X represents the number of shirts that are sold. It's not the price of the shirt. It's how many shirts. So that's why I always say write down what X represents, because when you solve for X, you want to know exactly what it means. Okay, so more interval notation. We've already kind of done this already. This is kind of a rundown of what we've kind of briefly talked about, but this shows it a little bit more. I kind of like this chart. And remember, these slides are all available to you also in your resources. If you just do a search for 1.3, you'll find exactly this. So remember, when you say bracket from A to B, it represents everything between A and B, including A and B. When one of them is a parenthesis, it means you don't count that. It's everything but that, but still the A. This is the other way. This counts neither, but notice all four cases it's what's in between. Then of course you've got the negative infinities and infinities. So you've done this, we've done this already before. This is just sort of a review of that. Now we're going to talk about a little bit more here. In the table, if the numbers A and B, if A is less than B, they're the endpoints of the interval. Closed is when it contains it, open is when it does not contain them at all. Now, like I said, I'm going to swing through a lot of these slides a little faster because we've dealt with them, but we have the square function, just like this, just a reminder. You have your other quadratic functions, ax squared plus bx plus c, so this is another way to write a parabola, okay? There's a couple of ways, this is one of them. The domain is all your real numbers, the range is all the possible answers the function can be, all right? Now we talk about zeros. X-intercept is where your graph hits the x-axis. It's where y is 0, x has some value, but they're also called the zeros of the function. Okay, it's just another name, and it's a common name you use as you get higher in math here. So when we look at these x-intercepts, sometimes they exist, sometimes they don't, and The way we solve it is not the easy way, but the for sure way is we use this good old quadratic formula. Okay, again, something you've had before. If you have a standard form quadratic equation, quadratic is when you have a square for that first term. You take the coefficients, the a, the b, the c, even if they're positive or fractions, you put them into this equation, and that's going to tell you the solutions for x. It's going to tell you the zeros for x is what's happening here. So, other things we have the vertex form. So this first one's the standard form, this ax squared plus bx plus c. The vertex form is another way you rewrite your equation where it already has built in what the vertices are. Okay, and we're going to get to how to get that. But if you're in this form, whatever this number is that's with the x in the parenthesis, take the opposite of it, and that's the first component of the function, of the vertex, I'm sorry. And then whatever number's up here by itself, remember that shifting we did last section? That's the y value of the vertex, the point there. So this thing called completing the square, again, you've probably had that in algebra. We're going to go through that a little bit more in depth. That's a way how you can get this process, this vertex form right down here. Okay, and you can also find the vertex using a calculator. So we have that. If you have a graphing calculator, good. You're going to have a couple problems in your homework that will ask to do something with a graphing calculator, and that's where you can go to Desmos or any other online calculator. You don't have to go buy one as well. Okay, so completing the square. We're going to do this a couple times and probably in the homework. This is where you're going to take an equation that's in standard form, and you're going to do this thing to make it into vertex form, and it's called completing the square. There's a whole process for this. Okay, so the first thing we're going to do, and they ask you what was done here and why, but I'll tell you, you're going to take and you're going to factor out of the first two terms. So these two terms right here, we're going to factor out whatever number it is, and basically you want to keep the x squared by itself. You don't want anything in front of that x squared. So how to do that? You pull out a -3, that's what's out in front here, and remember, when you pull out a -3, it's like dividing every of those, just those terms, by -3, and what you're left with is an x squared and a -2x. If you're ever not sure, go back and distribute, and you should be left with the same thing you started with. Okay? So that's our first step. Okay, so now what we're doing is, this is the process. So notice the only thing that's different is this 1 and this 3 right here, and I'll talk about what this is. This is the step called completing the square. All right, now your book may not go through this in depth, but I'm going to go through it. What you do is, before we do this, after you've factored, so that number that's in front of the x, my little formula is you take a half of that and then you square it. That's the step called completing the square. So that becomes a -1 squared, and that becomes a 1. This is the magic number that we add right here. That's going to create what we call a perfect square trinomial, and you'll see how that factors in a second. Okay, but what you have to remember is that 1's on the inside. So you don't have to do this every time, but if you're not sure what it was, I added a 1 to make that, I followed the steps I just showed you on the bottom right. That 1 I added, if I was to distribute that 3 out, now you're not going to do this, but if you were, again, notice these are exactly what's there in the beginning. This is the new part. Okay, so even though I added a 1, it's really a -3 times 1. So it's like I put a new -3 in there. To balance it, I put a +3. You use the opposite number. So take the front, multiply it to the number that you just added, and whatever you get, put the opposite right here. That's what you're going to get. So that's how we keep the equation balanced, because you can't just go along to an equation and start adding or subtracting numbers, but you can as long as you do the same thing. So I subtracted a 3 and then I added a 3. Then we're going to simplify and we're going to also factor. Now, what happened right here is I factored this and we get an x minus 1 and an x minus 1. If you've done the completing the square properly, you're always going to get a parenthesis when you factor that's the same two things. my little cheat for you, that number right here inside the bracket, it's always going to be the thing that you put inside the factor here and here. Okay, but if you check it, x minus 1 times x minus 1, sure enough, is going to give you x squared minus 2x plus 1. So we factored that correctly. Because they're the same factor, you can rewrite it as x minus 1 squared. And then, of course, these two things combine, and that's where that 2 comes from. And now we are in the standard form of the vertex. So remember, to find the vertex, I know it's going to come up in the next step, but right down here, it's the opposite of this. So it's a 1, and then it's exactly the same as this one. Okay, and that 2 right there. So there's your vertex at 1, 2. So all that moving around of the numbers, that's just to get you to put it in the correct form, and then once you have it in the correct form, then you're able to get the vertex just by pretty much eyeballing it. Okay, so the graph has a quadratic function that opens down since the leading coefficient is -3. Now that's another part. I haven't talked about that yet, but I'll bring it up right now because it's here. Whatever the number is right here, that tells you which direction your vertex points. If that's positive, it's going up. If that A is negative, it's pointing down. So that tells you that right there. It's the same number that's going to be down here when you put it into the vertex form. Same thing. But that's a shortcut. You can just eyeball it, and you can look at it, and you already know. When I see this equation, I see that -3, I know this thing's pointing down. I don't know anything else about it, but from looking at it, I know just from the plus minus points down. Now we have our vertex. And now we're going to do a different approach. Okay, same equation, but now we're going to find the intercepts, the x and y intercepts. And this you've done before, but you may have forgotten it. When I want to find the y-intercept, that's when you put an x in place of a 0 in place of x. So that's like finding f of 0. Plug in a 0 for x, all those x's disappear, and the only number we have left is a -1. Therefore, my y-intercept is 0, -1. To find the x-intercept, we set the entire function equal to 0. You let the y be 0. So you put 0 equals -3x squared plus 6x minus 1. And then if you can factor, factor. If not, you have to use this quadratic equation. Okay, the quadratic formula. -b plus or minus the square root of b squared minus 4ac, all of that over 2a. And plug things in. The only thing I'll make sure to remind you of is sometimes there's a negative, like this -b, so you do the opposite of that. Whenever you replace something, I always recommend a parenthesis. So that this a is a -3 in a parenthesis. This c is a -1 in the parenthesis. Even this 6 right here, I would put in a parenthesis just to get it, clear. Then you clean it up, we get this, and then you simplify it some more if you can. In this case, we're just going for a decimal, and that tells you that you have 0.184 and also 1.816. And notice what they did here was this first equation is the positive of the square root. See, that's a plus or minus. That literally means write this whole thing twice, once with a positive in front of the root, once with a negative, and then you can plug everything into a calculator and get some decimals to round. Those are your x-intercepts, and remember, those are also called your zeros. Excuse me. So, going through a couple of things, general properties here. A is not going to be 0, opens up, opens down, there's your vertex. Axis of symmetry. So, looking at a parabola, what the axis is going to be, if I've got a parabola say that points down here and here's my vertex, the axis is always this down the middle spine that kind of breaks it right in half, and it's always going to be x equals h. And if you remember, this is always a vertical line. Whatever h is, that's where your dead center is going to be. That's what the axis of symmetry is. And then the last part, you have a minimum whenever a is greater than 0. Remember, a greater than 0 is one where it points upwards, so your vertex is going to be a minimum. Whenever a is negative, it's pointing down, so your vertex is going to be a maximum. Our domain is always going to be all real numbers for a standard parabola, and then your range depends on what your vertex is and if it points up or down. So it depends on that. You see a couple shortcuts right here. Then we'll look at a couple of graphs. Let me clear your screen here. Okay, go back. So when you have an A positive, it opens upward and it looks like this. Here's my axis. Here's my vertex. Minimum value is the vertex. My domain is all real numbers, it doesn't show, but my range is everything from the vertex up to infinity. When A is negative, it's downward. Same thing, x equals h is the axis symmetry, your vertex is the top, and your range is going to be everything from the vertex down, from negative infinity up to this k value. So this is a good page here just to kind of summarize how these all look. Okay, so now we're going to talk about solving this inequality. So, solving an inequality. You get a typical quadratic inequality, I should say. You get something like this. The first trick is we're trying to find out where does that function, that quadratic function, be greater than 0. Okay? So, if you think about it, that is an equation of a parabola still, and this a value in front is a -1, so that's why they're saying a is -1. So this thing's going to point downward. Okay, and you're going to see a graph on a graphing calculator like this. What they're asking for is they want all the places this parabola is greater than 0, and they're talking about the y values. So specifically, we're looking for all the places the parabola is above the x-axis. These spots right here. And what they're asking, in effect, is what are these x values that make the graph go higher? Which x values make that true? Okay, so in the calculator, if you do a graphing calculator, it'll tell you those points precisely, so you can get them. You can still use the quadratic formula, but in these particular problems, we're going to use a graphing calculator just to show you how that works, how you figure those out. You just plug in the equation, have it graph, and you see what you get, and it'll tell you those precise points. So a couple other ones. These are just some examples of some other ones and what they're doing. When you hover over it, it's going to tell you the x and the y, and you know you've got the right one because you get y is equal to 0. Okay, so a couple points. Oh, and right there, I'm sorry. This is how you're going to write the solution of the problem. Remember, we're talking about what are the x values that make the equation be above the line, what make positive numbers. It starts at x equals this, all the way over to x equals that. Okay, another example of a problem here. Peach orchard farmer, 20 trees per acre. Talks about how much a tree produces, and we have the trees reduced by 10. On average 300 peaches per tree. And then how many trees should the farmer plant to achieve maximum yield? All right, so kind of get the idea here. Number of peaches per tree times the number of trees. Current yield is 300 times 20. So go back right here. On average, 300 peaches, 20 trees. Okay, now they're saying that every time you get an additional tree, it's going to make sure the number of peaches per tree is reduced by 10. So right now it's 300 peaches, but if you plant another tree, you're going to lose some. That could be for a number of reasons: shade, resources, water, people to pick, anything here, lots of reasons. So right now we have this. Now if we have the additional one, it's going to decrease. So look what happens is for one extra tree, it's going to go from 300 down 10, but you're going to get an extra tree here. So you're gaining one, you're losing on the other. 290 times 21, we get 6,090. So notice, excuse me, it has gone up. Okay, but as you start doing this more and more, you're going to see what's going to happen. Now we get 300 minus 20 because we got 2 extra trees. We're getting 2 extra right here, so 280 times 22, and all of a sudden we're at 6190. So it is rising, but at some point the question is, if we plant too many trees, is this 300 going to get down so low that it's not going to work anymore? So we have to create a model here, and this is what we have. This is the equation. So remember, X is the number of additional trees. Not total trees, but this is important, the additional trees. So whatever X is, we're going to do 10 times that, and that's what we're going to subtract. Then we're going to take 20 and add the X, so we get this equation. Now, notice they didn't show the work. What they did here is they foiled this out. 300 times 20 gets the 6,000. Negative 10x times x gets you the 10x. Negative 10x squared. Then we get a negative 200x and a positive 300x. That's where the 100x comes from. But this is the model. This is the key right here. So it's a parabola that's pointing downward because, again, that first term is going to be negative. And now we're going to find the vertex. The x-coordinate for the vertex is going to be the maximum. So remember how a down parabola works. Oh, and I forgot to erase this, which actually is good because this parabola is what's going on. Okay? Kind of like this somehow. We want to get the maximum. So this is the number of peaches produced, the yield. Let me just say that. The yield. If anybody's not sure, that's how many peaches you're going to produce. This is the number of extra trees. Okay? So what we want is, we want that number at the very top. Okay? We were over here, then over here, and it starts going up. But if we went too far, like I said, now it starts going back down again. We want to know what that top value is. That's the goal here. Trying to figure out how many extra trees should we plant based on the factors that are involved, and that'll give us the maximum number of peaches that we can produce. Okay? So we take this, and now what they did was that we're going to do the completing the square to get this into the vertex form. So we factor out that 10. Remember, you do that only from the first two terms. Factor out the negative 10 because you want the x squared always to be positive. Then we have a negative 10x. So remember that trick I showed you. You take half of this, which is negative 5. You square it. That's 25. That's the new number right here. Then you take the front number, if there's a number. If there's no number here, then it's just 25. But we take this, and that's equivalent to a negative 250. Okay, that's what these are right here. That's a negative 250. So to balance that, we put a positive 250 over here to the right. That's how they got that 250. So you essentially subtract 250 and you add 250 at the same time. You keep a balance. Then you factor this, and remember, this will always, because you completed the square, it's always a perfect square trinomial. So it's always going to be a factor of this case, x minus 5, something that's the same. Then we add the other two numbers, and now we know the vertex is going to be at 5 and 6250. There it is. So what that tells us is x was the number of extra trees. If you add 5, you're going to get the perfect highest number. And what's great is we know the number. It's the 6250 right here. So that's how many peaches we're going to get if you plant 5 more trees. And now you can kind of look this in a graph a little bit, and that's your high point right there. That's your 6250, and it tells you 5 more trees. So instead of guessing and playing with it or going and calculating each one at a time, if you can set up this model, now you know plant 5 trees and we're going to get our maximum. Okay, so 5 additional trees get the maximum, and now we're going to do a break-even analysis, or a break-even type problem. I'll do a couple more of these, then I'll get to some examples out of homework here for us. In this case, financial department produces digital cameras, revenue and cost functions for X million cameras with a production between 1 and 15 million cameras are as follows. So this is the revenue, and remember that's the millions of cameras you produce. And then your cost is this. Both have a domain between 1 and 15, meaning we're not going to produce less than 1 million and we're not going to produce any more than 15 million. It'll be a different model if we do that. So find the break-even points algebraically to the nearest 1,000 cameras. So remember, the break-even is set these two functions equal to each other, and we're going to solve for x. So here's the revenue and the cost set equal to each other. And then what this is almost always going to be is it's going to be another quadratic, just like this. Okay? Sometimes it'll factor. Usually in real-life applications, we're not going to factor, so we're going to go back to our quadratic formula. Plug all these numbers in, and like always, I'm going through this kind of quick on the video here. Remember, you can always pause it and just look and make sure you're clear where every one of these numbers came from the quadratic formula. All right, so when you solve, don't forget, you're going to get this plus or minus. That means you have two equations. One of them has a plus, one of them has a minus, and you're going to get two different answers right here. Okay? So now the company break-evens when they manufacture 2.49 million cameras or 12.53 million cameras. And that's kind of a weird concept, but what's happening is that's your exact spots, and you'll see that in a second. If you produce too many more, you're going to start getting a loss because it's going to be another, looking at this, you'll see the other equation in a second, but you have a case where too many is going to be a loss, too few is going to be a loss, and right in the middle is where we're trying to hit. We're trying to figure out where is that perfect spot. Okay, so graphical solution. When they say a graphical solution, that's when you're going to go on Desmos or use your graphing calculator and try to figure out what it is. So here's what's happening. Your revenue is going to be this function. That is your parabola going downward, okay, that we used on that peach problem last time. Your cost is a linear function. Notice there's no square. This top one is a square. If you were to distribute the x, you get a negative 5x squared. This has just a single x, so it's a line. And when you graph them, they look like this. So this is your cost. Remember, your cost goes up as you make more. Your revenue, like that peaches, it's going to go up, 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 then it's going to max out, and then at some point it's going to go back down. All right? So this is what's going on. So the break-evens, that's why there was two of them right here. Where the lines intersect are the two. So if you did this on a graphing calculator, you just hover your mouse right over that intersection, and it tells you intersection, and it tells you the actual values at 2.49 and at 12.52997. If you go back a couple of slides, remember, this is what we found when we did the quadratic formula. Okay? At least rounded pretty close. All right? Now, the company should manufacture either 2.49 million or 12.53 million to break even, but as you all know, we're looking for the perfect value. So go back to the pictures here. Nobody wants to break even. You're trying to make a profit. So as long as you sell in between these, that's where the profit's going to be. Okay? And we'll get to that in a bit. I don't know if it's going to be today or next time, but this difference in between these, this is how you can gauge your profit. So, sorry, draw you. Hold on. Okay, so that line right there is your profit margin. You've heard that before. This is your revenue right here. This is your cost. So if you sold this many, that line is your profit. If you're over here, you see the line's much smaller. Obviously, we talked about if you're right there, you're break even zero. So here it's a little profit. Here it's a little bit more. Here is probably your highest that you're trying to get to. You want the longest line, the biggest profit margin. Then as you start getting too much, now you see it starts going down. And if you go too far, this is the negative. And same thing over here, these are negative. So you're trying to find the one that has the best possible scenario, that line right there. Okay? So look at what linear regression is. Talk about that for a second. You're going to analyze and you're going to find the matches as close as possible, the best fit line. That's the key right there. Okay? Now, a scatter plot graph is where you have a data set and it's not always going to be in a perfect line. Like you're calculating profit or you're calculating how many you sold and how many you made. And the lines may be all over the board, but you're trying to find the best line that represents them. Okay? So, in this particular case, you can do this, this scatter graph, this plot here, you have all these. Let me show you how these dots look. Okay, so now on these, I'm going to tell you right now, this last part, I'm not going to make you do a whole lot of this right now. I might throw some of these in the homework, but on the quizzes, I'm trying not to put these in here because I know all of you have different calculators, and it's not required for this course. So you'll see some in the homework when it's just practice, but you're not going to see them on the quizzes each time. So just kind of going in here, this walks you through it. I'm not going to go through it too much right now because I want to focus on the other problems we have. This is just showing you what you would do, and what it's going to do is it's going to set up, and we get to it, and this is where the points are, and then you want to just create the best line or parabola that represents them. So that's what a lot of these steps are. Don't worry about them too much, like I said, because I'm not going to quiz you on them too much, just to show you what you have. Okay, so at this point, I'm going to go ahead and stop this part, and I want to pull up your actual homework assignment. Just do a couple of these problems here for the rest of this video. So once again, if you log into the course, I'm already in here. Click on your assignments, and you'll notice, at least when it comes up this week, you'll start to see there's more assignments that are showing up. I told you these are going to appear every few days. You're going to see more of these. Quiz 1 is due Monday night, the 24th. Homework 2 is already open once you've, and all these will disappear once you have the, if you had the syllabus quiz done, then you can jump right into homework 2, and then quiz 2 is there, but you can't get into it until you get enough points on the homework number 2 here. Okay, it's always going to be that way. And homework 3 is already up there for anybody who's really ambitious, but obviously I recommend you kind of going in order here. So just do a few of these problems here. I've kind of picked a few here. These are wrong, but I'm just going to pick on a few of them just to show you what we're talking about. Okay, so looking at a few, just to make sure we're all on the same page. Graph the equation. Okay, get used to working with this graphing tool because that's how it's going to be. Now, there's a number of ways to do this. My main recommendation is going to be, in the beginning at least, go find some intercepts. So if I was to make a table right here, I would go plug in a 0 for x to get the y-intercept, plug in a 0 for y to get that one, and see where these points are. These are the recommended points a lot of times because they're a little bit easier to do because the math is a lot easier when you're dealing with a 0. We all know that. So here's my original equation. If I plug in a 0 for x, I get a 2y equals 6 because this term, the first term cancels off. I get a y equals 3. In the same equation, if I plug in a 0 for y, I get a 3x equals 6, so I get an x equals 2. Now we have 2 points. And people always ask, well, how many points do you need to graph a line? Minimum, you need 2. I always recommend getting a third point just in case. But let's plot what we have. We have a 0, 3, we have a 2, 0, and there's my equation. There's my line right there. It does it all for you. Now, like I said, I'd recommend getting another point. Let's go plug in 1 for x. So we get plus 2y. 2y equals 3, y equals 3 halves, which is like 1.5. So I just wanted to check when I plug in 1, and let's see if I can zoom in on that again. When I plug in 1/1/2, there it is. It just kind of confirms it's on the line. I could have plugged in 8 to that equation, and I probably would have gotten a -9. Any other third point is good just to make sure, okay, this is good. I figure I can't have all these points wrong if all 3 line up. And then I would check my answer, and we're good. Okay? So I'm going to skip around and just do a handful out of section 1.3. Let's look at this number 7. Find the slope and the y-intercept of this equation. All right, so on this one, we have 7x minus y equals 14. Now, in case you're not clear, whatever form they give you, if you want to go get the slope and the y-intercept, you want to get your equation into this form right here. Y equals something times x plus some number. First step, get the y by itself. So I just move over that 7x and make it a negative 7x. Divide everybody by negative 1, and we get y equals 7x minus 14. So now I know my slope is 7, and I know my y-intercept is 0, negative 14. And that's all I need to plug in right here. Slope is 7. Good. Y-intercept. And now this is important because I always tell my students to write it in the equation form, or sorry, in a point form. All right. Now, you notice they marked it wrong. It's because when they just ask, they asked for the X-intercept. Anyway, okay, never mind. If they wanted the Y-intercept, a lot of times they just want the number. Okay. Now, to be clear, they want the X-intercept. So we've got the slope. To get the X-intercept, it doesn't matter which equation you choose. You can choose this one, or you can choose that one right there, any one of them. To find the X-intercept, we're just going to put in a 0 for the y. It doesn't matter which one we use. I'll take that first equation right there, put a 0 in for the y. So I get a 7x equals 14. And then divided by 7, I get x equals 2. And there's my X-intercept. Now remember, it's a coordinate like this. So let me test it one more time. Technically, the X-intercept is a coordinate. When I check my answer, it doesn't like that. If you see that on the homework, remember, they just want the coordinate, the number, the 2. Okay, and I say that because a lot of times people wonder, oh, why did I get that wrong in the quiz? If this is my quiz, I would be in trouble because I would have typed that 2, 0 and got it wrong. Okay, if you're not sure, this is where the homework comes in, because the homework has these problems that you're going to see on the quiz, so there shouldn't be anything new to you. You should have already experienced it and realized, okay, what are they asking for? Oh yeah, I got it wrong when I put in the point. Now at worst, if they ask for an intercept and you put in the coordinate and not the number, I'm not going to mark you wrong. The computer will mark you wrong, but I'm hoping you'll go and email me and say, look, I put in the full point. You know, the coordinate system, the x, y, can I get that point back? And I'll fix that without a problem. So check your work and let me know if you do get something marked wrong that you clearly had right. Now in this case, they want you to use the graph to get the x-intercept, the y-intercept, and the slope. Okay, so if I look at the x-intercept, remember, it's where the graph hits the x-axis. Now I see a negative 10 here, and it looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like my x-intercept is going to be at negative 1, where the graph hits the x-axis. Okay, the y-intercept. And again, don't be afraid to zoom in here. It looks like it hits the y-axis at negative 3, down 3 spots. So type in a negative 3. And last, write the slope-intercept form of the equation of the line. Okay, so we got to find the slope first. So finding the slope, that's another challenge. Okay, there's an equation that we're going to use. You saw that earlier. It's that m equals y2 minus y1 over x2 minus x1. All right, what it requires is we need 2 points. Well, when you have intercepts, you have points. For that x-intercept, it's not, this is why I was emphasizing this earlier, it's negative 1, but it's the coordinate negative 1, 0. And the y-intercept is the coordinate 0, negative 3. So if I call these my 2 points, which I can, that's x1, y1. This is x2, y2. I'm going to replace everything into here. So I get a negative 3 minus a 0 all over a 0 minus a negative 1. That gives me negative 3 over positive 1, which gives me a negative 3, and that's my slope on this one. Now, sometimes it is going to be the y-intercept. Sometimes it's a coincidence. It's always a coincidence. It's just sometimes it's how it is. Now we need the equation, and this is where you have to know your equations. Sometimes they ask for the slope-intercept like this. Sometimes they ask for the point-slope form. Sometimes they ask for the standard form of an equation. You have to make sure you read what form they want up there. This one is the one they want. So remember that checklist I gave you earlier. To use this, I need the slope, which we just found. I need the y-intercept. Well, do I have the y-intercept? Yeah, I do. It's also -3, so there's my equation. Okay, and now we'll do some more like this. I'm just kind of going every 4 here just to give you a little sample of what you're going to see on your homework. Okay, on this one, they ask you to find the vertices, the intercepts, the vertex, the maximum, and the range. So there's a whole slew of things that are being asked on number 15 here. Okay, so first off, all you have is this graph here. And like I'm doing, I highly recommend you blow this thing up to get a better picture of what's going on. So they want you to look at all this from the graph. So the intercepts, they ask first for the y-intercepts. Now, normally you should have only one y-intercept. They have this intercept or intercepts here. Y-intercept should only be 1. So I'm going to zoom in on this one. It looks like it's 19, 18, 17, 16, 15. -15 looks to be my y-intercept. Okay, now we want the x-intercept or more. And keep in mind, you can have on a parabola, you typically have 2. In this case, you see there's 2 places I collide with the x-axis. Sometimes it's 1 when the vertex is on the x-axis. Sometimes it completely misses the x-axis, so you have to make sure you're aware. So my first one looks like it's at -3, and the other one looks like it's at +5, right here and right here, where it touches the x-axis. So we have, and again, why I have you do the homework, this is where it's important. Use a comma to separate your answers. Well, one of them is -3, one of them is 5. It's not a parentheses. It's not a, a point. It's 2 separate answers, and there they are. And I believe if you typed in 5, -3, you were going to be just as good. Now the vertex, and they tell you right here, see, type an ordered pair. That means they do want an x, y. So let's do this. Let's get the zoomed in picture. Then we're going to zoom in some more. Looks like it's at -1, and it looks like it's at -16. So, -1, -16, and check your answer. Oh, did I miss it? Check it again. Oh, +1, I'm sorry, right here, +1. That's why it's good, it's homework. Fix that again. Now I'm going to give you, hopefully let's check and make sure this is right. There we go. Now, a little trick I'm going to tell you. It's eyeballing it, you can get it. If you've got the 2 x-intercepts correct, I'm going to tell you a little shortcut is, if you've got 2 x-intercepts, find the average of them. So if you add up -3 and 5, you get 2, divide that by 2 because there's 2 terms, the average. The answer is 1. That is the vertex. Vertex is always going to be in the dead center of your intercepts, no matter where the intercepts are. So you can get the 1, and if you have an equation like you have right here, you can just plug that 1 in, and you can get the answer. Or, remember, this function is already in, what do you call it, vertex form. So you see, opposite of this is +1, and that number is -16, you have it there. Now we look at maxes and mins. If this graph is pointing up, there is no maximum. It goes up to infinity, but there is a minimum, and that value is the vertex, which is -16. They're asking what's the minimum y value. If this parabola is pointing down, then there would be no minimum, and the vertex would be the maximum. And your range, remember, if it's going up, it's going to start at that lowest point, that -16, and it's a bracket because you include it, and it's going to go all the way up forever to infinity with a parenthesis, and that's my range. All right, so that's it for number 15. And now we're going to look at number 19. Same kind of thing here. We're going to find all these things, but this time there's no graph. All right? So I'll walk you through how I would do this one. First step is, because that's a positive x squared, whatever that term is, that's your a. Don't forget. That a is positive, so before I do anything else, I know one thing, this graph is going to point up, which tells me I'm going to have a minimum, I'm not going to have a maximum, upward parabola. So now they want the intercepts. First thing, Y-intercept. Easiest one in the book, you put a 0 for x, and it looks like we have a 32. Supposed to be the easiest one. Did I miss? Oh! Go back. Okay. I guess I didn't read this. I'm looking at A here. They're asking for the equation in vertex form. So we got to do a little bit more work here. Okay, sorry. I jumped the gun on the 32. Part A, look at what they're asking us to fill in. This is a lesson you'll learn from me on this one. Let's get this into vertex form. So remember how this goes. First thing is you factor out any number in front of the x squared. Well, if the x squared has nothing in front of it, then I don't have anything to factor. I just do this. We're doing the completing the square again. Okay, then we take half of that number 12, which is 6, and we square it, and that's a 36. So I added 36 to balance it. I subtract the 36 right here. And that gives me an x plus 6 times an x plus 6. And that becomes a minus 4 back here. Now I have an x plus 6 squared minus 4. That is in vertex form. That's what they want here in this first step. So I missed that. And now I hope, okay, they're not liking me. Okay. So, what did I miss here? Let me make sure I didn't mess up any signs, and I did mess up one right here. You guys see when I pulled this equation down, I messed up the sign. It's supposed to be a minus 12x. Hopefully, as you're going along, you caught that as I typed that in there. That was not intentional. So how is that going to change? I'm just going to kind of change this on the fly here. We complete the square. That's half of negative 12, which is negative 6. And then square that, it's still 36, so this part doesn't change. When I factor it, however, this is going to change because this is going to become a minus 6 and a minus 6. So I apologize for that. Now it's a correct factor. Now we have it in the right form, and I hope, third time's a charm, we get it there, finally. Okay. Now we do the Y-intercepts, and be careful, because they say use a comma to separate answers if needed. That's if there's more than one intercept. It doesn't mean use the ordered pair. And you'll learn that, by making that mistake. But we did this earlier. It should just be a 32. Okay, now we find the X-intercepts. So I'm going to go here in the middle of the board. And remember, X-intercepts look like this. There's a 0 for the A. For the Y component. So we take that entire equation and we set it equal to 0. Sometimes you're able to factor this. If so, do that, and then you set each of these equal to 0. You could also do that quadratic formula that we've done a few times, and that'll also tell you the answers. So 4 and 8 are my choices, and I got those. So like I said, if you factor and set each factor equal to 0, you get 8 and 4. If you did the quadratic formula, you'd get that as well. Now the vertex, remember, it comes from down here. It's the opposite. When we're in vertex form, it's the opposite of the number in the parentheses, your x, and then it's exactly this number on the back end, minus 4. That's your vertex. Okay, once you get this form, you should get the vertex just by looking at it. Now, Remember I told you this is an upward parabola. It's confirmed with this positive. So it's an upward parabola, so it's not going to have a maximum because it goes on forever, but it will have a minimum. And the max or min value is, right here at the bottom, is this vertex. Okay, so we haven't graphed it all the way yet, but at the point positive 6, negative 4, that's the vertex, and this parabola is going to go upward. So this is your minimum, and when they want to know the minimum or maximum value, they're asking what's the y value of the vertex, even if it's negative. That's what we have. Hopefully that's good. And we have that. And the last is the range. The range is all the y values. And when it's pointing upward, it starts at the vertex y value, and then it goes all the way up to infinity with the parenthesis. And now we've got it. Okay, so I got a little shaky in the beginning because I read the problem wrong and I messed up something over here. But here's all the parts. Lots of steps on this one, but that's the process. So pause that if you need to look a little more. If not, I'm going to go on to the next one. So let's look at number 23. Okay, so here we are asking for a solution set. Okay, now there's a couple ways you can do this. Here's kind of the way I'm going to teach you. It's a different way, but it's going to work. You can always look in the book. I like to go through the factoring approach. And then what I like to do is you set this equal to 0, because what this is going to do is this is going to tell you where your graph hits the x-axis. We have x-intercepts at 0 and -5. Now I could have done that in the very beginning, set the whole thing right here equal to 0. And I'm getting these two values, so it tells me on my graph I hit the x-axis at 0, and I also hit it over here at -5. Now, that part I circled up here, remember, it's like this equation right here. Now there's no number in the back end, that's okay. Because that's a positive, it tells me my parabola is pointing upward. So here's my two intercepts. I don't know how it looks, I'll just draw a dotted line because it's a mystery, but my parabola is going to look something like that. The question at hand is, where is my parabola greater than 0? Well, it's greater than 0 in a couple of places. It's asking where is it above the x-axis. Well, here it's positive, here it's positive, and since I know these points, I know from 0 on up it's going to work, and everything less than -5 it's going to work. So the question they ask for is, what's the solution set? Where is this thing going to be greater than 0? Well, I also know it cannot be equal to 0, so I cannot include the -5. If I put this in interval notation, it's going to go up to -5, but not including it, and then it's going to be the union, picking up from 0 up to positive infinity. That's the interval notation, and that's what I think they're going to want this in. So everything from -infinity up to -5. Not including that because again it didn't have an equal sign up here, then I'm going to union that, combine that with everything from 0 up to positive infinity, also with all parentheses, and that's our answer. Okay, so again, pause this if you need to look at it a little more. If not, I'm going to move on. All right. Let's look at number 27 here. And again, my pattern is I'm just kind of going every 4, and this hopefully will give you enough of a sample here. They want to know what's the maximum value of this. Okay. Now, they want you to find this graphically. So that means they want you to graph this and use it, use the use the answer that you get on the graphing calculator. So let me show you what I mean here. Let's see. Sorry, I'm trying to get this working a little better. Okay, so I'm going to go to Desmos. And the idea here is just to graph this thing as you see it. Now, when you type this in here, you can type this f of x, should work, and type it exactly as you see it. Most of the time, the mistake is people mistype the equation. Make sure it looks good, and now you see it's kind of a very ugly parabola, but you can kind of see what's happening. It's a very extreme one like this, okay? So my highest point right here, looks like it's at this 10,493. That's your maximum value. Remember, it's the y value, 493. Okay, you could have done the same thing a couple of ways. You could have tried to solve this, found it. You could have put this into completing the square and gotten it. Either way, it would have worked. Okay, in this case, that's our answer. That's all we need to do. So sometimes it takes a little more. Sometimes it's not that bad. Once you graph it, it's kind of an easy thing. Okay, let's do one more here. Now this one's a little more unique here. Make sure we can get the table right here. Automobile tire manufacturer, click the date in the table, and here's the equation. Mathematical models given, complete A through D. So complete the following table. They want you to plug this into the function, okay? So I'll let you kind of work on this one. I don't need to show this right here, but basically, I'll do the first one. We have this right here. Okay, move things out of the way. Now, the proper way to get the first one, when x equals 26, is we're going to plug it right in here. So we're going to find f of 26. So everywhere you see an x, that's a 26, that's a 26. Now, I can use my calculator to do this a little bit better. Make sure I got everything typed in correctly. Okay, so let's just look at this picture first. There's another downward parabola right here. Now the question they asked was, what's f of 26? So as I zoom in here, I can actually go and find 26 right there. Okay, now you just have to kind of follow the line up a little bit. And you see as I hover around or I click on it, I just want to go until I find 26. And this is the, eventually, right on it. Oh. Right there. We have 45.432. That's what they're asking. Okay, going to 53, I can do the same thing. Scroll down until I get to 53. I see it's going to be a little bit longer. There's still guides up here, but a little more. 53 is at negative 219,762. Okay, so see the process, that's all I'm doing in getting these y values. So I'll show you another trick here. Once you've set an equation, I can go plug in the numbers right here. See f of 26, 45.432. Without having to trace the line is what I'm saying. F of 20, oh, I did that wrong. I picked the wrong x, by the way. Okay, good. Good thing I caught that. f of 28 is what we're supposed to be, not 53. We're supposed to plug in f of 28. So that's why it's good to check your work here. That's actually 51.688. Some of you wondering what I was doing back there. My apologies. This is the first row that we need to pick. So I can find f of 30. See it right down here, 53.8. F of 32, 51.768. And f of 34, 45.592. And check them. Oh, I must have typed one in a little bit too fast. 45.592. And of course, I got to do this a little bit. Oh, I know what it is. Okay. Got to read my instructions. Round to the nearest tenth. That should be right there. This should be 0.7. That one looked good. This should be 0.8. This should be 0.6. And there we go. Now we're right. So I got it wrong just because I went a little too far. And that's another one. If you guys ever round further than they ask, I'll give you points on that one. If you round it too much, like if they wanted the nearest hundredth and you give me the nearest tenth, then you're going to get the problem wrong. So it's in real life, it's never wrong to go further. But in this case, the computer is very fickle on this one. That's what they wanted to see. Now they want you to sketch the graph of these. And a couple things you can look at. Remember, it's an x square. X square are parabolas that point up and down. So I know it's not going to be B. I know it's not going to be D. It's going to be one of these. It's a negative, so it's pointing down. All I have to do is kind of look at some of these points a little bit more closely just to see what I have here. Okay, so I've got a point right here at 26, 5, 6, 7, 8, 10. Yeah. I'll make sure we're counting by ones. So at 26, it looks like I'm at 43-ish. Yeah, so these are counting by ones. Make sure I'm getting the scales right. It's about 43. It's a little higher, about 43. I found it to be 45, so that doesn't look right. Let me look at this one. And at 26, notice that's a little bit higher where I should be. This looks like this is the proper set of dots right here. So that's my choice. And there's my answer. Okay, so on the rest of these, you can just kind of figure out what's going on here. Without doing them, I'll just kind of cut this off here. You can go to 26. You use the model to sort of plug that in. You can figure out what that one's going to be. Yeah, and this one, I plug in the 27. I'll just plug that in real quick. 49, and they want this to be about PSI, I think is what we're dealing with. Yeah. So 49.1 PSI. Okay, so I paused it by accident. Sorry, I missed this. But when I plugged them in here, 49.08. Notice I plugged in the 27 to the function down here. I got the 49.078. Now, what I didn't show, I first typed in 49.1 because this one said nearest tenth up here, so I did the same thing. Lesson. Make sure you read this. They wanted the nearest hundredth, 49.08. Then there was a drop-down menu about what the value is. So you have to remember, we're plugging into the function. Read this very carefully. It's got the tire pressure X, that's in pounds per square inch, and then mileage in thousands of miles is what the output is going to be here. Okay, so I typed in miles by accident, and it's actually thousands of miles. Here for 31, we'll hopefully not make this same mistake again. 53, and they want this the nearest hundredth, so we're going to type in 53.30, even though you should be able to get away with 53. And this is also, I believe, in thousands of miles, and we got that one right. Okay, and the last part here, write a brief description in the relationship between tire pressure and mileage. So what happens as the tire pressure goes up, what's happening? Well, we already saw this here. It looks like it goes up, then it goes down as mileage. There's like that perfect PSI that you need to get to. So the expected mileage first increases, then decreases, is what it looks like, with an optimal tire pressure of about, go to my graph that we picked up here. And I can actually go and look at it over here, back in the graph that I actually put right here. Looks like it's about 30-ish. That should be the one that they want. Yeah, multiple choice, so we got that one, and there it is. Okay, so I'll end that one right here. The rest of the problems are going to be on section 3.2, or sorry, 1.4 and 1.5. So this kind of wraps up 1.3. After this video, you should be able to get through about the first 35 problems of the homework, and I believe there's like 80 something. So this is the first third of it. Should be able to get through these. If you have any questions, shoot me an email, and then look in the next day or two to see similar videos for section 1.4 and 1.5. Okay, don't forget to have that quiz done by Monday night, and this will wrap up the section 1.3. Have a good one.